All right, so here's part 2 of lesson 7.1, evaluating an exponential expression. So what is the value of 2a to the negative second times b to the fourth, where a equals negative 2 and b equals 1? All right, so we need to do 2. We'll just substitute in for a negative 2. Actually, you know what? Let's simplify it first. I think that might be easier. Get rid of that negative exponent, then we don't have to deal with that. So what we'll get is 2 times 1 over a to the second, so that changes to that, times b to the fourth, which is 2b to the fourth divided by a to the second. Now let's substitute. So we have 2 times 1 to the fourth. So I substituted 1 for b, and then we're going to substitute negative 2 for a. And 1 to the fourth is 1 times 2 is 2. And then negative 2 times negative 2 is 4. And so we get 1/2 for that. Okay. When I first simplified that, remember from the last problem that really all you need to do when you have a negative exponent is make that part of the denominator with a positive exponent. So we just get a squared down there. If it has a positive exponent, it stays the same. 2 is the same as 2 over 1, so 2 would stay in the numerator for that. All right, so let's try another problem like that. What is the value of n to the negative fourth w to 0 for n equals negative 2 and w equals 5? So two methods. We could simplify it first and then substitute, or we could substitute first and then simplify it. So let's try it both ways. You can go ahead and try it. Pause here now. Come back and check your answers. All right, exponential expression. A population of birds doubles every 8 years. The expression 6,400 times 2 to the t power models a population of 6,400 birds after t periods of 8 years. Evaluate the expression for t equals 0 and t equals negative 2. Describe what each value of the expression represents in the situation. So let's start with t equals 0. 6,400 times 2 to the 0 is equal to, well, 2 to anything to the 0 power is 1, so that's just 6,400. And so that represents, so 0 represents the initial population. Okay, so we're not changing any years there. So the beginning population. All right, and then our other expression we're gonna evaluate for t equals negative 2, and that looks like that. And to evaluate that, that's the same as 1 over 2 to the second, which is 1 over 4, which is really 6,400 divided by 4, which is 1,600. All right, and what that means is that, remember that each power of t represents 8 years. So if we use negative seconds, what we're talking about is 16 years ago. So that's kind of like going back in time. What was the population 16 years ago? So t equals negative 2 represents 16 years ago. All right, go ahead, you try working with that. Check back for the answers. All right, so let's do a quick lesson check here. Student incorrectly simplified x to the n over a to the negative n b to the 0 as shown at right. Does the student work correctly with base x? It seems like base x has a positive n for exponent, so that'll stay in the numerator. So we'll say yes there. Base A has a negative exponent in the denominator, which would be a positive exponent in the numerator. So that should be okay. Yes. Base B, anything to the B power, anything to the 0 power is 1, and the student said that that's 0, so we're going to say no there. The student said B to the 0 equals 0, which is never true, even if B was 0, which we probably would define this as saying B could not be 0, but even if it was 0, it still is undefined. So we are going to simplify the equation by doing x to the n, a to the n in the numerator, and 1 in the denominator, which is any number divided by 1 is just that number. All right, that's the lesson. See you tomorrow.